This is Laura Duncan from CSMS, and today we're going to be discussing the properties of exponents. Much like multiplication shows repeated addition, exponents show repeated multiplication. So when it says t to the third power, we have t times t times t. That's how we expand it. So remember that the exponent is the small number to the upper right, and the t is the thing that's repeated. It's called the base. So let's repeat this one with a base of t repeated 4 times. Now to simplify this again, we simply count the number of t's that we have. If the base is the same and it's being multiplied, we can make it into an exponent. So this would be t to the 7th power. Let's look at number 2. On number 2, we have coefficients, the 5 and the 6. Those are coefficients and they are not being repeated. The base of s is being repeated with an exponent of 2 here. So let's expand this out so it will be more clear. We have 5 times s times 6, and then there's 6 s's being multiplied. We won't have to do this every time. It's just to demonstrate what's happening here. So as we try to simplify this, you'll see that we are going to multiply the coefficients of 5 and 6. 5 times 6 is 30. Now let's look at the exponents. We have a base of s being repeated, and it's repeated 8 times. Now what did we do? Let's put this into words. The property of exponents states to multiply powers with the same base, we'll add the exponents. So for every non-zero number b, that means it can't be a 0, we'll have b to the m times b to the nth power. Then we would simply add the exponents, m plus n. For example, we have x to the third and x to the second. So we would simply add the exponents. That would be x to the 2 plus 3, or x to the 5th power. Let's begin with number 3. The base is 2. So we copy down the base, we add the exponents. 3 plus 5 is 8. However, that is still not simplified. To simplify this fully, we would evaluate 2 to the 8th power to get 256. Let's look at number 4. Just to make sure that we are speaking the same language, I want you to understand that the numbers highlighted in yellow are called coefficients. So in this kind of problem, we will multiply the coefficients and add the exponents. So 2 times 3 is 6. The base is n, and it will remain an n, and we will add the exponents. The exponents are the ones in purple, 5 and 4. So we'll add the exponents. 5 plus 4 is 9. So this is the final answer. On number 5, it's basically the same type of problem. The only thing they've added here is parentheses, but it implies multiplications. So we will do the same thing. We'll multiply the coefficients. That's 2 and 14. So that would be 28. And we'll add the exponents. Now remember, each exponent is attached to a base. The base must be the same in order to add the exponents. X squared will remain x squared. The base of y, though, will add those exponents. 4 plus 3, that's 7. We'll check for any other simplifications that we need to do. There's nothing. It is simplified. Number 6 is the same type problem. We'll multiply the coefficients and add the exponents. So let's look at the coefficients of 10, 3, and 2. 10 times 3 is 30. 30 times 2 is 60. Now let's look at the x base. We'll add the exponents. This is where most algebra students make a mistake. This x has a power of 1. It's an understood power of 1 and it's invisible. This one has 1/2 and this one has an exponent of 2. So we have 1, 1/2, and 2. Well, you might want to make them into all halves. So you'd have 4 halves. You'd have 2 halves. So that'd be 3 halves plus 4 halves. That would be 7 halves. So we're just going to write it as an improper fraction. Now let's look at the base of y. We have 9 halves and 7 halves. So 9 plus 7, that would be 16 halves. That is still not simplified. So as we simplify that, 16 divided by 2 is 8. So let's rewrite it. We'll have 60 times x to the 7 seconds times y to the 8th. And that is our final answer. Please box, cloud, or circle your answer. Number 7, find the area in square units of a rectangle that has a width of 2x squared y squared and a length of 4x to the 5th power. So you have to remember to find the area in a rectangle. You will be doing length times width. It may help you to draw a rectangle. Now we'll simply substitute the length and the width into our formula, and then we'll evaluate it or simplify it. So we're dealing with multiplication, so we will multiply the coefficients and add the exponents. So 4 times 2 is 8. We'll add the exponents if the base is the same. With of the base of x, we will add 5 plus 2, so that would be 7. The base of y, we have 1/3 plus 2. If it helps you, make them both into thirds. So we'll have 6/3 plus 1/3, that would be 7/3. Leave it improper, we like it. So that's in square units. So please be sure to put your label on there and box, circle, or cloud your answer. You've done so well on multiplication. Let's go ahead and do some division. Please expand number 8 and 9. Now that we've expanded number 8, it will make it easier to see that when you have a b over a b, that will simplify to 1. So they kind of cancel each other out. This b over b is 1. So we are left with b to the 3rd power. Let's look at number 9. We expand it. This becomes a 1. This becomes a 1. And notice, it seems like there's nothing left in the numerator. Well, don't forget, they canceled out to 1. So this would be 1 over b to the 3rd power. Let's try to verbalize that into words so that you'll get a better understanding. In this property of exponents, to divide powers with the same base, you'll subtract the exponents. So when we're looking back at 8 and 9, notice that the higher exponent, b to the 5th power, was in the numerator. And so we ended up with b to the 3rd power. However, on number 9, the higher exponent was in the denominator. So when you're subtracting these exponents, I want you to look and see where the higher exponent is. Subtract them normally, and then whichever exponent is the highest, you'll put it in the same spot. For example, here in number 9, it's in the denominator. So you put the remaining b's in the denominator. Let's practice. We have 3 to the 4th power divided by 3 to the 3rd power. The base is 3. So we're going to subtract because we're dividing. So 4 minus 3 is 1. There's a understood 1 when we write it as just a 3. But I want you to notice the greater exponent is in the numerator. So that's why this ends up as a whole number 3 and not a fraction. Look at the next one though. The greater number exponent is in the denominator. So I want you to be sure that we'll put the remainder in the denominator. So 10 minus 3 is 7. So it will be a to the 7th power, but it will be 1 over a to the 7th power because a to the 10th is in the denominator. Let's look at number 10. We have a base of x, and we're dividing, so we'll subtract. I know that the x will be in the numerator because 3 is greater than 2. 3 minus 2 is 1, and there is an understood 1 there that I do not have to write. Now look at the next one. We have y to the 5th and y to the 2nd. We'll subtract because we're dividing, so that will be y to the 3rd power. It will go in the numerator. There's nothing in the denominator except a 1. So now that is my simplified answer. Let's look at number 11. On number 11, we have a coefficient now. We have 8, and remember it's division. So 8 divided by 2, I like to draw a line just so I know where I'm putting things. 8 divided by 2 is 4, and that will go in the numerator. Now let's look at the base of m. We're dividing, so we'll subtract the exponents. Well, it's clear that the 8 is greater than the 5. 8 minus 5 is 3. So in the denominator, we'll have m to the 3rd power. Let's simplify the base of n. The exponent is greater in the denominator, so that's where our final answer will go. 7 minus 4 is 3. Box, circle, or cloud your answer. On number 12, we have multiplication and division. So I prefer to simplify the numerator and simplify the denominator, and then simplify them both together. So since the denominator is already simplified, we can just rewrite it. Then in the numerator, we'll multiply the coefficients. So 6 times 3 is 18. And then a will be to the 4 plus 2 is 6. We're still not complete though. Now we go back to division. The coefficients are 18 and 2. That would simplify to 9. And then we have a fraction here. So we can make this 12 halves, and we have 5 halves. So 12 halves is greater than 5 halves, so the a will be in the numerator. 12 minus 5 is 7. So our final answer will be 9 times a to the 7 halves power. Pause the video and try number 13 on your own. In the final answer, notice n to the 3rd over n to the 3rd. That simplifies to 1. On number 14, the area A of a parallelogram is 36 times x to the 8th times y to the 7th square feet. The height h of the parallelogram is 9 times x to the 3rd times y to the 5th. The area of a parallelogram can be found by using the formula A equals b times h. Find the length of this parallelogram's base, b. So we know that the area is 36 x to the 8th, y to the 7th. I'm simply going to substitute it into the formula that they've given me. I know that I'm looking for b, the base. However, the height is also given, so I'm going to substitute that. 9x to the third, y to the fifth. Now, how do I isolate the b? I isolate it by doing the opposite. I will divide by 9x to the third, y to the fifth on each side. And as I do that, this side will cancel out to 1, and I'll be left with 1b, so that's the base. Now look at the coefficients. We'll divide the coefficients. 36 divided by 9 is 4. Let's look at the base of x. 8 minus 3 is 5. The 8 is in the numerator, so it will be x to the fifth power. Then we'll have times y to the second power. That is our final answer, and it's just units, so you can add that. And the lesson is yours.